So 4.6 part 2, examples 7 and 8 starts us off with number 7 here. This says we're looking for where y is equal to the inverse cosecant of 2. So remember, using the inverse, we're going to do the inverse of this, switch x and y. So we want to know 2 is the cosecant, sorry, it looks like a 5. 2 is the cosecant of what angle? Well, before we get going much further, let's think about what we know about cosecant. Cosecant is a reciprocal function, and it's a reciprocal of sine. So this is saying the same thing as 2 is equal to 1 over sine of y. And if I wanted to solve for sine, first I got to get rid of the fraction. And then move the 2 over. So we're really saying sine of what angle then would equal 1/2. All right, but remember, we're still dealing with cosecant, so you got to think about what the range for cosecant is going to be. And it told us that it was negative pi over 2 to 0, and from 0 to pi over 2, where 0 is not included. And that's because when we graph cosecant, 0 is a vertical asymptote. All right, so if you notice, this part of the inverse cosecant is almost just like inverse sine. The only difference is the 0 is not included. So you don't have to memorize a whole new thing here, okay? So if you know that inverse sine goes from negative pi over 2 to positive pi over 2, then its reciprocal inverse cosecant is going to go from negative pi over 2 to pi over 2, but it can't be 0 because 0 was the vertical asymptote on it. All right, so, but again, this just means we know that negative pi over 2 is down here in our unit circle. Positive pi over 2 is up here. So we're still looking for between them. So we're still looking in quadrants 1 and 1 and 4, but not 0. All right. So since we know that, now I'm going to use this right down here. So we know that sine is going to be positive. And so sine is positive in which of those quadrants? Quadrant 1. So, and we also remember this sine is y over r, and on our unit circle r is 1. So we're really just looking for where our y value is going to be a positive 1/2. And so look on the unit circle, quadrant 1, y is a 1/2, and that should be at pi over 6. So that would be our solution. All right, and moving on to example 8. Well, example 8 is similar to example 2. So we get y is equal to the inverse sine of 0.75. So I'm going to do the inverse. I'm going to switch my x and y. And so 0.75 is equal to sine of y. So we want to know the sine of what angle is equal to 0.75. Remember, inverse sine is quadrants 1 and 4. Sine is positive 0.75. So sine is positive in quadrant 1. So sine also, remember, is y over r. R is 1 on the unit circle, so we're just looking for the y value. So look in quadrant 1 at your y's, and which one is 0.75? None of them, right? All right, so like example 2, we got to go back up here and look. Remember, inverse sine says it has to be between negative 1 and 1. Is it? It is. On example 2, it was not. Remember, it was a 5. And this one, it's a 0.75, so that is in the domain, which means it's just one of those angles that's not on our unit circle. So this one really should have been like a separate example completely. It should not have been under the directions to find the exact value of y, because this is going to be a calculator problem. All right, so in our calculator, you're going to type in the inverse sine, which is your second sine button. But first, remember, you got to remember, do we want our angle, because we're looking for an angle, that's our y value. Do we want our angle to be in degrees or radians? Well, everything with inverse, unless it tells us otherwise, is always going to be in radians. So make sure your calculator's in radian mode. And then you're going to type in the inverse sine, which is that second sine. Remember, I told you back when we first started trig functions, you don't hit the second button unless you're looking for an angle. We're looking for an angle here. So the second sign of 0.75, hit enter, and let's round it to 3 decimal places. And so I believe you should get 0.848. And so that would be our solution there.